The term stronger than steel used to be synonymous with great strength, but today many manufacturers are using new lightweight materials called composite materials rather than steel. This is because composite materials are generally stronger, lighter, and much more resistant to extreme temperatures than steel. NASA is using composite materials to make new spacecraft and aircraft parts that are tougher and more efficient than conventional parts. Derek Leonidoff takes us to the Advanced Materials and Processing branch at NASA Langley to find out more.
Have you ever heard the term composite materials? Even though most people don't know exactly what they are, there is no doubt that these materials are being used by most of us every day. More and more of the goods we use, like tennis rackets, golf clubs, cars, and even planes, are made with these materials. But do you know what a composite material is, or how one is made? Well, I spoke with researchers at NASA who are developing new composite materials that are not only lighter and safer than existing materials like steel, but also stronger. These researchers are also working with radical new materials called nanotubes that are thousands of times smaller than a human hair, but they may revolutionize the way future materials are made.
A composite is really a generic term which describes a material that is composed of one or more parts. And those parts are combined together in a way that you end up with a final material that has better properties than any of the individual components. An example of a composite that we see every day is a tree. A tree is composed of cellulose fibers that are bound together by a polymer called lignin. And when you combine these two components together, you end up with a tree which is very, very strong.
A composite material is made when a combination of two or more materials are combined together to make a new and different material. Researchers take individual materials, one a reinforcing material for strength and stiffness, and one a glue or binding material, such as a resin, to surround and hold the reinforcement in place. When the reinforcing material and the binding material are combined, they make a new material. This new material usually is not only strong and resistant to extreme temperatures, but can be much lighter than the existing materials.
Similar to the tree, an analogous synthetic material is a graphite composite. A graphite composite is composed of carbon fibers which are very, very strong. And to make a structural material using these carbon fibers, we consolidate it by combining it with this polymer matrix resin. This polymer matrix resin is kind of like a glue. And this is a large part of the research that we do here at NASA. Depending on the properties of this particular polymer, it will dictate the maximum temperature that you can use it at, and also how strong this material is.
One of the ways that we can use the glue that Joycelyn talked about is to make it into little balls called microspheres. As you can see, it's mostly air. Since it's mostly air, you have the combination of a strong material that's also lightweight. What we do is we take the balls and we consolidate it into a foam piece. And because, again, the material is strong to begin with, you now have a very tough, lightweight structure. We then take this structure, combine it with carbon fiber. What we have done now is to have a lightweight structure that improves fuel efficiency, therefore it reduces the cost of travel, and we also have improved safety in aircraft travel.
So Mia, what is the future of composite materials? I mean, where do we go from here?
One of the things that we're looking into now is called nanotechnology. Nanotechnology presumes that we're able to go into the atomic level, move atoms, so that we can create materials in a very controlled manner. That way we can design materials very precisely. In the current technology, we use wires embedded in structures to sense defects in aircraft parts. We are trying now to reduce the size of these wires so that in effect we have nerves embedded in aircraft structures. Because carbon nanotubes are about 80,000 times smaller than human hair, we can embed many of them in an aircraft wing, for example, where they can perform a function similar to the nerves in our body. This technology will allow the wing to respond to changes in temperature and pressure in the atmosphere by changing their shape without using mechanical flaps. Because of this ability, we can now design the aircraft of the future to be safer and much more efficient. We think about biological systems like us. When we get cut, our body heals itself. Those are cells that are forming and going and doing their job. What we want to do is be able to get that kind of control over the types of materials that we make. Although we know that we want to get to a smart plane using carbon nanotubes, we don't know how to get there yet. And as Einstein said, if we knew what we were doing, it wouldn't be research. So that's the excitement of the work that we do.